Hey, welcome to The Explainer. Today, we're diving into one of the real unsung heroes of the mechanical world. We're talking about the device that lets these tiny little motors pull off incredible feats of strength, the thing that makes so much of our modern world possible, the helical gear reducer. So yeah, let's get right into it.
So to really get why these devices are so important, we've got to first understand a really fundamental problem in engineering. It's this classic trade-off, the battle between speed and power.
I mean, really think about it for a second. How can a pretty small motor on a factory conveyor belt move literally tons of stuff? Or how does a robotic arm lift a heavy car door with, perfect precision? It just seems like it shouldn't work, right? Well, the answer is all about fixing a basic mismatch.
And this is where you hit a snag. A standard electric motor, it's amazing at one thing, spinning really, really fast. But all that speed comes at a price. You get very little rotational force, what engineers call torque. The thing is, most of the big jobs, the heavy-duty applications, they need the exact opposite. They need slow, super-controlled movement with a ton of force behind it.
So how do you fix that? How do you bridge that gap between high speed and high power? Well, you bring in a translator, a sort of mechanical middleman. And that, right there, is the gear reducer. To put it simply, a gear reducer is just a gearbox. Its whole job is to act as that mechanical translator we were just talking about. It takes the raw, high-speed energy spinning out of the motor and converts it into focused, low-speed, high-torque power, which is what the machine actually needs to do its work.
And the way the power flows through it is actually pretty simple. Kind of elegant, really. It all starts with the motor, which gives you that fast input. That energy then goes straight into the reducer. That's the gearbox, where all the magic happens. And what comes out the other end, from the output shaft, is that slow, powerful, and totally usable force.
Okay, so how does this little box pull off such an amazing trick? Well, it all comes down to the beautifully simple physics of gears.
This right here, this is the core idea. Just picture a small gear spinning like crazy, powered by the motor, and its teeth are meshed with the teeth of a much, much bigger gear. Now, you might be wondering about that helical part of the name. Well, instead of straight teeth, helical gears have teeth cut at an angle. And that's a game changer. It means they engage more gradually, which makes the whole thing run smoother, quieter, and yeah, it can handle way bigger loads. You're giving up speed, but what you gain is incredible power and control.
If you've ever ridden a bike with gears, you already get this. It's second nature. When you get to a really steep hill, what do? You shift into a low gear. Your feet start pedaling way faster. That's your high-speed input. But the back wheel turns slowly, giving you the force you need to get up that hill. A gear reducer is doing the exact same thing.
All right, let's put some numbers to this to make it super clear. Let's take a common gear ratio, say 10:1. All that means is that the input gear is 10 times smaller than the output gear. So for every 10 full rotations of that little gear, the big one only turns once.
And this is where you see that beautiful trade-off in action. At a 10:1 ratio, the output speed is cut down to exactly 1/10 of the motor's speed. But the torque, that raw rotational force, gets multiplied by 10. You see, you trade speed for power. It's that simple exchange that makes almost all of heavy industry possible.
All right, so we've talked about what it is and how it works. But the big question is, why does this matter? What are the actual real-world payoffs that make these things so absolutely essential?
It really boils down to three huge benefits. First up, increased torque. This is the brute force you need for things like cranes, industrial mixers, and conveyor belts. Second, simple speed reduction. You need a bottling line or an escalator to move at a safe, predictable pace, not the crazy top speed of a motor. And third, and this one's huge, precision control. That slow, controlled movement is absolutely vital for things like robotics and automated manufacturing, where getting it right every single time is everything.
So when you step back and look at the big picture, the takeaway is pretty clear. The gear reducer isn't some optional add-on. It's the essential translator. It's the critical link that takes the raw, almost chaotic speed of a motor and turns it into the useful, powerful, and precise work that literally builds and moves our world. So now that you know about this, you're going to start seeing it everywhere. I mean, from your car window rolling down, to the conveyor belt at the grocery store, to a giant robotic arm in a factory. This principle of trading speed for power is all around us. The only question is, where are you going to spot it next?